So, right, good evening to everyone. So, yesterday, I stopped up to here this lead, right? Okay. Actually, my time is 8 to 9, but I have another class UG. So, that's why I'm taking before class instead of Dr. Srinivas sir class. So, Srinivas sir will take the class 8 to 9. So, I will take the class daily 6 to 7. Okay. Right. So now yesterday up to lead is over. Then next hydrocarbons. So hydrocarbons. Hydrocarbons. So these are otherwise known as volatile organic compounds. It means VOC, right? So they are essentially fuel which was unburned, right? Unburned, not burned, unburned during combustion process or which has escaped into the atmosphere through fuel evaporation. Through what? Fuel evaporation, right? So the hydrocarbons can often be divided into separate categories. So those are methane, CH4, and non-methane, NV, NM, VOCs, right? Non-methane volatile compounds. Okay. So the vehicles are also major source of atmospheric hydrocarbons. So hydrocarbon emissions result when fuel molecules in the engine do not burn. Do not burn means you see here here also unburn. Unburn. Do not burn means unburn or burn only partially. Right? So do not burn or unburn or burn only partially. So the hydrocarbons react in the presence of nitrogen oxides and sunlight. Sunlight means UV rays, right? So sunlight to form what will? Ground level ozone, O3. So the a major component of smog, right? So the ozone irritates the eyes, damages the lungs, and aggravates respiratory problems. So it is our most widespread and intractable urban air pollution problem. So it's a number of exhaustly hydrocarbons are also toxic with the potential to cause to cancer, right? So these are the hydrocarbons, and lastly, carbon dioxide. This carbon dioxide. So the carbon dioxide is increasing in the atmosphere due to combustion process, right? So that is involved in the burning of oil, burning of coal, and burning of gas. So it is one of the most abundant greenhouse gases, right? Greenhouse. So greenhouse gases comprising how much? 72%, right? 72% of the total by weight. And the others being methane and also fluorocarbon, CFCs, and nitrous oxide, right? So the earth is kept warm by solar energy trapped by the atmosphere, right? Trapped by the atmosphere. So it is becoming widely um, accept, accepted that the temperature of the earth is increasing by approximately how much? 1 degree, right? 1 degree Celsius. Every 30 years. See here. Okay. You see, one 1 degree Celsius. So every 30 years. Okay. So it's a process widely known as, what is that? Global warming. Okay. Global warming. So the carbon dioxide is not a pollutant of concern to human health, but it is considered to be an environmental problem because of its contribution up to global warming. So now currently the transportation of accounts for 25% of total carbon dioxide emission, and the pressure to tackle increasing traffic volumes, that is enormous, right? So in response, many national governments are taxing fuel in the hope of curbing the growth in vehicle owners or ownership, right? So the some of the local governments are encouraging the use of park and ride, and also alternate transportation systems in urban areas. So the automobile engines need to be aware of the wider effects of pollution, right? You see here the carbon dioxide, methane, and gas molecules. So that have similar structures may influence the global climate by internal molecular vibration and rotation, which cause these molecules to absorb infrared radiation, IR, right? IR, infrared radiation. So the carbon dioxide is a greenhouse gas, I already told about it. So which is a major player in global warming, right? So other than the emission of these harmful gases into atmosphere, increase in motor vehicles, it has also increased congestion, accidents, oil spills, noise related problems, and different various disturbances to local flora and fauna also. So in recent years, the US Environmental Protection Agency, EPA, US EPA has started to view carbon dioxide. So a product of perfect, right? Perfect combustion as a pollution concern, right? Perfect, perfect combustion. So the carbon dioxide does not directly impair human health, but it is a greenhouse gas. So that traps the Earth's heat and contributes to the potential for global warming, right? So this is the carbon dioxide. You see, this is the picture, and ultraviolet radiation plus nitrogen oxides plus, that is, gives form to volatile organic compounds and this smog. Okay. So I will tell next slide. This is the world vehicle per driving age population. Okay. So these are the years from 1960 to 2020. Right. And also you observe this one, and these blue are motorcycles, and yellow are commercial vehicles, and this red are cars, right? So this is the years from 1935 to 1990. So these are the millions of vehicles, right? Millions of vehicles. So you see from increasing from 1935 to so 1990. You see here, but motor vehicles are also from 1975 to 1990, right? But cars are 1935 to 1990. So increasing, you see how much from 100 to 4, I think up to maximum 500, right? 500 millions. or 400 million plus, right? Now is the effects of human health. So those are headaches, eyes, nose, and throat irritations, and impaired lung function, and coughing and wheezing. So these are the effects of the human health. You see some of the pollution matters. This one, okay. So now you see here. So preventions. What are the preventions? What are we improving? So these eliminating the use of old vehicles, right? And also ban of inferior technologies used in automobiles, diesels, etc. And creating effective and efficiency transport system. And also these are also very important. Good road conditions nowadays. So roads are very bad, right? So mainly in rainy season, right? And effective, fast and responsive traffic management, and also use of clean and good quality fuels like CNG, LPG, and improving the design of automobile like fuel efficiency. And you people can help by driving less, and also use the public transport vehicles available, and make a habitat habit of maintaining your vehicle like clean air filters and oil filters and carbon deposits, etc. And also use of low emission vehicle. These are very, very important. Low emission vehicles, right? So the introduction of very efficient petrol vehicles emissions control systems will contribute to emissions. So my suggestion is, so maximum allow, allow you use EV electronic vehicles, right? Electronic vehicles. Okay. Right. You see here this UV rays mixed with nitrogen oxides plus volatile compounds. So it forms smog. So how to form smog? UV rays plus nitrogen oxides and volatile compounds, right? So now you see here. So, right. First, what is smog or what is photochemical smog? Right? So the photochemical smog. Smog is air pollution. So this um, that reduces visibility, right? So the term smog was first used in 1905 by HA. So HA base BOEUX works. So in the year of 1905 by HA Days VX, that is to describe a blend of this fog, right? Fog and smoke, SMOKE, smoke. So it found over many British towns. So fog plus smoke is called smog, right? So this smog can be of two types. So that is classical or sulfurous smog. So, and photochemical smog or industrial smog. So, the great smog of in the year of 1952 in London. London is an example of sulfurous smog. And also it's called London smog. Okay, London smog. So this articles deals with photochemical smog and components, formation and effects and also prevention. Right? So what is photochemical smog? The photochemical smog, also known as summer smog. Summer smog. So it is formed when this ultraviolet light from the where? From sun. So it reacts with the nitrogen oxides and volatile organic compounds, right? So it is visible as a yellow-brown haze during the morning and in the afternoon. So the photochemical smog tends to occur more often on dry and summer days when the region experiences the smog sunlight, right? So the main source of pollution affecting the air quality in the Adelaide metropolitan area are motor vehicles and also domestic wood, burning heaters, while in regional centers and industry, often it has the largest impact, right? So the Environmental Protection Authority or agency that monitors the pollutants in our air at a number of metropolitan or regional cities or locations, that is to determine whether the air quality is satisfactory for maintaining human health and well-being. So now it is this smog. It is characteristics of urban areas and is thus commonly found in densely populated cities. It means okay, Los, okay, Los Angeles, Angels, and Sydney, and Mexico, and important thing is our India in New Delhi, and last one Beijing. Okay, so these are the most densely populated cities, right? Los Angeles, Sydney, Mexico, and New Delhi, and also Beijing, right? So among many others, right? Many others also. So it is also sometimes it referred to as Los Angeles smog. It's called Los Angeles smog. So I already told before the London smog, and this is called Los Angeles smog, right? So what are the components of photochemical smog? So that is photochemical smog required neither smoke nor fog, right? Neither smoke or nor fog. So it mainly consists of this nitrogen, right? Nitrogen. What is that? Nitrogen dioxide, NO, right? So nitrogen dioxide and ozone and pan. It means peroxylacetyl, right? Peroxylacetyl, nitrate. And organic compounds, it containing the aldehyde group. Aldehyde, aldehyde group. So now, what causes photochemical smog and what are the conditions? So now, so this air pollution is formed when the solar radiation react with the primary airborne pollutants emitted from automobiles and industries and also power plants, right? And etc. etc. So some common examples of primary pollutants are nitric oxide, nitrogen dioxide, nitrous oxide, right? And most volatile compounds. So during in morning time, that is peak traffic hours, right? So the night in the time the nitrogen oxides and volatile compounds are hugely released into the environment only in morning peak time, that is traffic of hours, right? So the natural calamities such as volcanic eruptions, forest fires, and microbial activities also contribute to nitrogen oxide and nitrous oxide. So when these primary pollutants are exposed to the sun, right? This sun's ultraviolet radiation and NO2, it goes through a series of complex reactions with hydrocarbons to form. What is that? More secondary pollutants such as ozone, peroxyacetyl and nitrate and nitric acid and aldehydes, aldehydes and also others. So the combination of all these chemicals cause the formation of photochemical smog. Now, how is photochemical smog formed? So the stages for photochemical smog formation is given. That is, I already told yesterday, right? So now I'm telling. So in the morning, the nitrogen is burned or oxidized when released from automobiles. That is to form nitric oxides in an oxidation step, right? So the nitrogen into plus nitrogen plus oxygen formed to 2NO. It's called nitric oxide, right? Nitric oxide. And second one is, so within a few hours, the nitric oxide, it combines with more oxygen in another oxidation reaction to form nitrogen dioxide. That is this 2NO nitric oxide and oxygen. It gives or it forms 2NO2, nitrogen dioxide, right? And third one is mm, nitrogen dioxide, right? Nitrogen dioxide absorb sunlight, right? Absorb sunlight, and it means UV, right? UV. So that is breakdown forming, what is that? Nitric oxide, NO, and oxygen radical plus oxygen radical means O, right? So in a reduction of reaction. And so third one is over. And fourth one. So fourth one is, what is that? Oxygen. Oxygen radicals react to atmospheric oxygen. That is O2. Right? So that is to form, what is that? Ground level of ozone, O3. Okay? And fifth one is ozone. This ozone, this O3, this O3 ozone is consumed by nitric oxide, NO, NO, right? Nitric oxide, it's to produce, what is that? Nitrogen dioxide, N2O plus and oxygen, O. Okay? So this reaction is reversible. And sixth one. So sixth one is this nitrogen dioxide, NO2, react with volatile organic compounds, VOCs. Those are, it's called hydrocarbons, right? So, and such as hydrocarbons to form secondary pollutants. What are the secondary pollutants? Such as peroxacetyl nitrate, that is called PAN. PAN. Okay. So these are the 6 reactions is very important. So now, why is this photochemical smog bad? Why it is harmful effects? So now, so on human health, first of all, it causes irreversible damage to the lungs and also heart and causing emphysema and bronchitis and asthma. So some of the persons with allergies, right? So even a brief exposure to photochemical smog has a lasting effect on both the young and elders, right? So it causes painful irritation in the respiratory system and reduces lung infections or lung functions, and it makes it difficult to breathing problems also. So it also causes pneumonia, fatigue, and heart problems, right? So when combined with hydrocarbons, it forms molecules that causes eye irritation. So some volatile organic compounds can cause cancer also, right? So this is on human health and environment. On environment, it has devastating effects on the environment that affects growth in both. It means plants and animals, right? So the production is smog sensitive crops such as tomato and tobacco and spinach. So these are significantly reduced, right? The ozone causes death problems, right? That is, it patterns on the upper surfaces of the leaves of trees, right? The ground level ozone also interferes with the growth and productivity of trees. So the animals life is also affected, right? So that is similar to its effects on humans. So free oxygen radicals in the air interfere with the nitrogen cycle and prevent the destruction of ground level ozone. And other effects are it corrodes metals, right? Metals and stones and painted surfaces, right? Painted surfaces. So it can also cause a reduction in the tensile strength of textiles and fading of dyed fibers, right? So now, how to prevent or how to reduce chemical smog, this photochemical smog. So the photochemical smog is related to severe consequences, right? In urban areas where automobile pollution is very high. So it is the responsibility of humanity to reduce its effect and to get the community involved. Some ways of controlling the formation of smog are reduce dependence on vehicles and use public transportation instead of driving, and reduce dependence on non-renewable energy resources. So that are the primary sources of air pollution. And also install panels to trap solar energy that acts as an alternative source of energy. And lastly, use smog detectors and use monitoring systems so that act as easily warning systems for air pollution. So now what are the primary pollutants of photochemical smog? Those are first one is mm, first one is nitrogen oxide, NOx, right? NOx. So these are emitted from vehicle exhaust, industrial processes, and power plants, right? And second one is volatile organic compounds. So these are emitted from vehicles exhaust, industrial process, and gasoline vapors and solvents. So now the major primary pollutants, nitrogen oxides and volatile compounds. So combine the change in sunlight in a series of chemical reactions. And sorry, outline below, and to create what are known as secondary pollutants. So what are the secondary pollutants? So the secondary pollutants that causes the most concern is the ozone, right? Ozone that forms at ground level. So while ozone is produced naturally in the upper atmosphere, and it is a dangerous substance when found at ground level. Okay. So many other hazardous substances are also formed, such as peroxyacetyl nitrate, that is called PAN, etc., etc. Right. So now, so this is the photochemical smog. So now, how can we reduce the occurrence of photochemical smog? the most effective way of reducing the amount of secondary pollutants it creates in the air is to reduce emissions of both primary pollutants, right? So the reduction of nitrogen oxides, the main method of lowering the levels of nitrogen oxide is by a process called catalytic reduction. Catalytic reduction, RUDUCTION. So, which is used in industry and in motor vehicles. So, for example, so a catalytic inverter filter that is to car's exhaust system will convert much of the nitric uh, oxide, right? Nitric oxide from the engine exhaust gases, it's to nitrogen and oxygen. So in Australia, all motor vehicles built after 1985 so must be fitted with this catalytic converters, right? So the nitrogen is not in the actual fuels used in motor vehicles or power stations. So it is introduced from the air when combustion occurs. Okay. So the using less air in combustion can reduce emissions of nitrogen oxides. And the temperature also has an effect on emissions, right? So the lower the temperature of combustion, the lower the production of nitrogen oxides. The temperatures can be lowered by using processes such as two stage combustion and gas recirculations, right? Flue gas recirculations and water injection or by modifying the designs of the burners. Now, reduction of volatile organic compounds. What are the reduction of volatile organic compounds? So there are various ways, right? Various ways that is to reduce volatile compounds emissions from motor vehicles. So these includes the use of um, liquefied, right? Liquefied petroleum gas, that is LPG. 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 Liquefied petroleum gas or compressed natural gas. It's called CNG, right? CNG gas. Compressed natural gas rather than petrol, decreasing distances vehicles travel by using other modes of transport. It means such as buses and bikes and implementing various engine and emission controls. So now being developed by manufacturers, right? So the other major contributor to volatile organic compound emissions, however, it is not a simple to police because the solvent evaporation occurs in many different places, from large factories to backyard sheds. And control strategies to reduce these emissions must be widely varied. So how can you do the help? So here are some actions you can take to help minimize the pressures on our environment. You can also tell me some of the helps or reduces this smog. That is keep your motor vehicle regularly serviced and the tires inflated to the manufacturer specification emissions. So this will ensure the car is running efficiently and not emitting excessive pollutant, right? So keep your motor vehicle service, okay, regularly. So now next one is when you trade in your old cars and replace it with a fuel efficient, low emission cars or electronic vehicles. So check out the fuel consumption label, which now it has to be displayed on new cars. So for commercial vehicles, the alternative fuels conversion program is now some places is available, right? So instead of using a car, try riding a bike or walking and use buses and trams or trains. So whenever you can, okay? So and use energy efficient appliances. So look for the energy star logo when buying a computer, printer, or a scanner, TV, VCR, radio, audio, DVD products, etc., etc. So are the energy rating on the next air conditioner and cloth dryer, washing machine, dishwasher, fridge or freezer. So you purchase, right? So next one is if renovating or building, use energy efficient design and materials. And next one is turn off necessary electrical appliances at the power point, whatever if possible. Okay. Next, make it your goal to purchase green power or green. Okay, system is problem. So now generate your own green power in investigable. Get the state government solar hot water rebate and photovoltaic rebate and the remote renewable power generation grants, right? And limit your wood fights at home and wear warmer clothes as your first action to keep warm. So if you are buying a slow combustion wood heaters and make sure it meets the Australian standards. And those are AS4013 and is installed currently according to in Australia AS2918, right? So instead of AS4013. And schools can get involved with AirWatch and a program for primary and secondary schools where students can become pollution watchdogs in their local areas, right? So my computer is stuck. So what happened?